Solar panels have amazing promise, but serious limitations. They're expensive to produce, and it's in the name, you need sun to power them. So what if there were a way to make solar panels cheaper and functional even in places with limited sunlight? And what if I told you the key to this is bacteria? I know, color me surprised, and also green twice, because this whole discovery makes use of photosynthesis and E. coli. Ew. But first, let's talk about how solar energy traditionally works. A solar panel is made up of subunits called photovoltaic or PV cells. For a PV cell to work, it has to generate an electric current, so each end of the cell is made up of either a negatively or positively charged material, usually silicon mixed with either phosphorus or boron. This creates a pre-existing electric field, and when this field gets exposed to photons, aka sunlight, that knocks some electrons loose from the silicon. Other components of the solar cell then organize those free-floating electrons into an electric current that can either be used or stored. We talked about this in a video here. Silicon is a semiconductor that's used in all kinds of electronic applications. But now, new work from a team at the University of British Columbia came at this system from a totally different angle. Solar cells powered by E. coli. They've genetically engineered bacteria to produce large amounts of a pigment called lycopene. This is a light-harvesting dye that gives tomatoes their red-orange color and is photoactive, meaning that in its native state inside a plant, it's extremely effective at converting light into energy. In this case, the lycopene is what's being excited by the light to release an electron instead of a synthetic material like silicon. But the bacteria aren't a semiconducting material. For the energy the E. coli have absorbed to be transferable, the team had to coat the bacteria in titanium dioxide nanoparticles, or TiO2. And then, ta-da, these light-absorbing, mineral-coated bacterial cells are now semiconducting. They're then attached to a glass surface doped with oppositely charged materials, and between the lycopene, nanoparticles, and doped glass, you've got yourself an electric current induced by light. This is a huge leap in biohybrid PV technology. Other technologies have used light-harvesting bio-based dyes in solar cells, but extracted the dye from the bacteria, which is expensive and difficult. This new method is cheaper and easier because it keeps the pigment inside the bacterial cells, and it uses a new technique to coat the bacteria in the nanoparticles. Not only that, but this new experiment also yielded almost twice the electric output of previous bio-based PV experiments. That gives a whole new meaning to the term green energy, and if you need me, I'll be cackling about it to myself for the next 15 years. Okay, let's address this though. I thought E. coli caused disease, right? It's actually a super common bacteria we use in research all the time. There are lots of different strains, most of which can be found in the intestines of humans and other animals, and only some of them are dangerous. Most are really useful, and we couldn't live without them in our systems. We use E. coli in the lab because it's easy and inexpensive to grow, and we can hack its genome to get it to produce the protein, or in this case, pigment, that we want it to. These new bacteria-powered or biogenic solar cells are looking promising not only because we're making gains in how much electric current they produce, but also because these PV cells, unlike synthetic ones made out of materials like silicon, can produce just as much energy in dim light as in bright light, because the lycopene is so effective at harvesting energy from the sun. Still, there are a few details that need to be straightened out before these live solar cells are ready for market. For one, the bacteria die during this process, so we've got to figure out a way to keep the poor little guys alive, reproducing, and producing lycopene through the lifetime of the solar cell, so you don't always have to go in and replace the bacteria. Plus, this prototype currently produces about 25 times less power than a traditional solar cell, so the design of the device would need to be significantly improved before it's a feasible option. Regardless, this is an exciting way to reimagine solar panels that work in areas that don't get a lot of sun. Plant power plus bacteria power equals my favorite combo in the whole world. To learn more about the insane power of bacteria, check out my previous video on how they may be controlling your mind, and subscribe to Seeker to keep up with all of the energy technologies of the future. And speaking of bacteria, E. coli was one of the first organisms to have its genome sequenced. I'm Marin. Thanks for watching.